Alright, today I'm going to go over Firestarter 13. Here is where we're going to start with. I drew the picture, so I just drew a triangle. I know it's triangle A, B, C. Alright, I also know D is in the middle, so there's D. Now this should actually say, that's a typo, that should say DC. So the first part, triangle ABC is isosceles. That is given. D is the midpoint of AC. So you always start with statements and reasons. Always start with given. That should be the easy stuff. Now the next thing, AD congruent to DC. So I'm basically, what they're telling me is the proof is saying this guy right here is congruent to this guy right here. Well, that's because D is in the middle of AC. Well, that's what it says right here. So the reason we actually get to say that is because that's the definition of midpoint. Now BA congruent to BC, so we're saying this guy right here. I'm going to do a different color. We'll say this guy right here is congruent to this guy right here. Well, why is that? Well, they told me that the triangle is isosceles, so I know I get to say that's the definition of isosceles. Now the next one that's a little bit harder for you guys is, how do we know that BD exists? Well, the definition of a line segment is that I can connect any. So if I know that I can connect 2 points with a line, it's called a line segment. So that's a definition of a line segment. So right now, we don't have like vocab tests in geometry, but you do have to know what words mean. So you have to know what word midpoint means. You have to know what isosceles means. You have to know what line segment means. Now, one that everybody really gets pretty easily, it looks like, is here. We're going to say reflexive property. That's because remember, there's only a couple things that are just like, look at the picture. One of them is the reflexive property. Now see, look, that line is part of both triangles at the same time. It's part of the left triangle and the right triangle. So that's why it's the reflexive property. Now, do I have enough information? So what I do is I always like to I like to say if it's a I like to write down, so like that's a side statement. That's a side statement. That's neither. These are neither. This is a side statement. So I look at over here. As soon as I see that there's two side statements, I knew right away it couldn't have been either of those. I know it can't be hypotenuse leg because there's no 90-degree angle. So before I even get to 5, I should have known it's either side 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 or side angle side. But when I want to get to 5, I see that I have 3 side statements. So this is going to be side side side. Now, because I have side side side, I get to fill in the rest of the triangle. So I get to say that this guy right here is congruent to this guy, and this guy right here is congruent to this guy, and this guy right here is congruent to this guy because they're corresponding, right? So angle A corresponds to angle C, angle B corresponds to angle B, and angle D corresponds to angle D. So does BAC, so B to A to C, is that congruent to B to C to A? And it is, and the reason for that is CPCTC. CPCTC, corresponding parts of congruent triangles are congruent. So that always follows after side 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 or side angle side or triangle congruency theorem. That's going to happen all the time. So really, you should know how all your proofs start and how all your proofs end. The hardest part is going to be the in-between. Alright, that's it for that one. Alright, I'm going to start off Firestarter 14, and I'm going to talk about angle relationships, because whenever we want to find congruent triangles, we want to either be able to say sides are congruent or angles congruent. A lot of you struggle with finding the angles, and usually parallel lines are going to lead. So parallel lines are usually going to lead to angles being congruent. For example, alternate area interior angles are congruent. That means like C is congruent to F, or D is congruent to E. We also know that alternate exterior angles are congruent, so I could say like A is congruent to H, or B is congruent to G. We could also say corresponding angles. That means like A is congruent to E, B is congruent to F, C would be congruent to G, D would be congruent to H. So anytime we have something like that, parallel lines being cut by a transversal will always help me out there. All right, that's going to be an important concept whenever we see parallel lines in a triangle proof. It's almost always going to lead to a congruency statement. All right, so we're going to come back. We'll use that a lot, and we'll come back to that a little bit later. So now, remember, we have from the other page, we have 5 choices already, right, that we could use. We could use side, side, side. We could use side, angle, side. We could use angle, side, angle. We could use angle, angle, side, and we could use hypotenuse leg, which we haven't talked a lot about yet. We'll be talking about that in the upcoming week. Now, I know my proof will always start with statements and reasons. So even if you tell me you're lost, you should at least be able to do this part: statements, reasons. Now, I'm always going to write my given. So I'm going to start with my given. HV is parallel to GI. Now, I always call that a neither statement because it's not saying side congruent to side or angle congruent to angle. So even though it's talking about sides, they are not saying side congruent to side, so it's a neither statement. It will not help me with any of these. Alright? Not help me with any of those. Now I'm going to take my second given, that's the second statement. HG is parallel, don't forget the bar on top, VI. And once again, that is a neither statement. The keyword is protein. The keyword is protein. Now, the reasons for these are given, right? Because it was given to me. Now, my recommendation for you is whenever you see parallel lines, whenever we see parallel lines, so that means this guy, HV, is parallel to GI. So if you see parallel lines, you need to find a transversal. This is the transversal. So if you have parallel lines cut by a transversal, this angle right here and this angle right there are called alternate interior angles. And since they're 2 parallel lines cut by a transversal, we get to say those are congruent based off that picture and angle relationships we already learned. So I get to say angle VHI is congruent to angle GIH. The reason for that is alternate interior angles are congruent. Now I always put 2 parallel lines cut by a transversal right there to remind myself I should have 2 parallel lines cut by a transversal. Now, this statement right here led to that statement. So see how I use, if I have a neither statement, it's probably going to lead to either an angle or a side statement. That's an angle statement. Right, so that was led to it by, now I'm just erasing so we can see things. And so that's still true. Now, so that means more than likely, I'm going to use this statement for something. Well, this is the parallel line, and I still have a transversal. Right? Now notice I see that this guy right here is alternate interior to this guy. So I can say those two angles are congruent. So I'm going to say angle GHI is congruent to angle VIH and the reason for that is the same reason above. Alternate interior angles, although it's a different set of parallel lines because I have two parallel lines cut by a transversal. So that's why it's important to understand, what do parallel lines tell me? Well, parallel lines didn't tell me that the angles were congruent. I had to remember that parallel lines cut by a transversal have some angles that are always congruent. So this angle is alternate interior to this angle. This angle right here is alternate interior to this angle. So now I have an angle statement. So I kind of look at my choices here. There's no way it's side, side, side because I have angle statements. There's no way it's side, angle, side because I have two angle statements. And there's no way it's hypotenuse, leg because that usually deals with a 90-degree angle. So it's either got to be angle, side, angle, or angle, angle, side. Either way, I need to have a side statement, whether it's this one or this one. So I need to be able to figure out some information that I can use. And I already used both givens. Notice the first given gave me the first angle statement. The second given gave me the second angle statement. So I need to just be able to either use those givens again, which for right now, parallel lines do not usually lead to sides being congruent. What I need to be able to figure out is there any way that I can just look at the picture and use a side statement? And we do have something like that. We have something where, look, this red line is part of the top, bottom, and the triangle, bottom triangle at the same time. That's called a shared side. So I get to say IH is congruent to IH, and the reason is reflexive property. Now, the order that you write this, and this does not matter. You can write it in any order you'd like, right? The order does not matter. The order does not tell me which one of these it's going to be. The order does not tell me it's going to be angle. You have to look at the picture for that. So I'm going to just fix my picture again. So remember, I had this from the first set of given. I had this from the second set of given. And the reflexive property told me that was true. So I look at to know whether it's angle, side, angle, or angle, angle, side, I look at my red line. Since it is touching both angles, that's in between. Alright? So this is angle, side, angle. So I know it's going to be angle, side, angle. Now, here's how you write the triangle. Remember, the order matters greatly. I'm going to start with the bottom triangle. And I'm going to start with right here with I, it's the blue. And then I go to the top triangle. H is the blue arc, or the one arc. Now I go to the left triangle, or the bottom triangle. H is the two arc. I is the third arc. G is no arcs. And then V is no arcs. Now, remember, we could fill out the rest of this triangle now. I can say this guy is congruent to this guy. I could say this side is congruent to this side. I can say this side is congruent to this side. So any of those marks I made in black, dashes or arcs, can be a CPCTC statement. So you pick whichever one you want, because I told you just pick one. So if you want to say if you want to say HG is congruent to IV, that's fine. You could also say GI is congruent to VH. You could even say angle HGI is congruent to angle HVI. All of those are CPCTC.